Today's lecture is going to cover how to draw Lewis structures for covalent molecules, and we're going to focus on the more standard rule-following options. So the series of steps that you see written on the slide are going to explain a strategy for how to draw the Lewis structures in an efficient way. Our goal is to show which electron pairs are by themselves or alone, and which electrons are in shared pairs, which represent bonds. So the first thing we need to know, you'll know step one, is to count the total number of valence electrons in the molecule. In that situation, we'd look at our periodic table. Remember, what column it's in helps us determine how many valence electrons there are. Then we're going to write the element symbols for each atom and kind of spread them out with the least electronegative element in the middle. The only exception to this rule is hydrogen is always going to be on an outside because it can only do one bond. Then I'm going to connect the outer elements with single bonds, straight lines. That represents a pair of electrons. Once I have that set, I'm going to add electrons in pairs only, so each element has 8. That's our octet rule. The only exception to that is since hydrogen is so small and only has room for 2 electrons, it can only have a single bond and will not have any pairs of electrons around it. What I now do is I look back and I count my total electrons and make sure it matches what I identified in step 1. If it matches, we're done. We've done it correctly and everything fits. There is the possibility that it doesn't match up. So now we have to do some evaluation steps. So I have to make sure that I actually counted the number correctly. I want to double count and make sure that I have the number I thought I did. Then I also want to make sure that everything has 8 except hydrogen, and those are valence electrons. And if both of those are true, then there's some possible rule breakers that I can do to make the set work within the rules that do exist. But we're going to start with the ones that should work out correctly. So we're going to do it for 3 different substances. Now our H2, if I'm going to follow my rules, it says to draw them without anything and then connect with a single bond. And first I have to determine valence electrons. So when I look, that line counts for 2 electrons. They are single connected, and 2 is the total that I was supposed to have. This is my Lewis structure for H2. Now F2, I'm going to count up my 7 valence electrons times 2. I'm going to draw them apart and then connect them with a single bond. And now I'm going to fill in with pairs to make sure that everything has 8. So you'll notice on the left fluorine, I'm going to add 6 electrons in 3 pairs, because when I count that with the line, there's going to be a total of 8. So when I account for the bond counting for both fluorines in this situation, both of them get to behave like they have 8. But now I'm going to count the total. So if I count up all the individual electron dots plus 2 for the line, I reach my total of 14 that I was supposed to have. So let me just erase quickly and redraw the final diagram. And the last one we're going to try is carbon tetrafluoride. So this is one where that least electronegative going into the middle is going to be really important. So the carbon is left of fluorine on the periodic table. It's less electronegative. So between the 28 electrons coming from fluorine and the 4 coming from carbon, I will have 32 in the final drawing. So I've drawn my elements, and I've drawn them with the straight lines. Now I go back in and add electron pairs to get to 8. So if I look at each fluorine, they have 1 line and 6 individual electrons for a total of 8. And the 4 lines connected to carbon also represent that carbon meets the octet with 8. Now, since each fluorine represents 8, if I count that and multiply times the 4 of them, 8 times 4, my drawing has the correct number of valence electrons for what I started with. So the most important part is the total number of valence electrons must match the total I expected from what the valence electrons come in with. Now the next type of particle is going to throw a little monkey wrench in. We're going to look at polyatomic ions. So the only difference is that in this situation, the polyatomic ion has a charge, which means the number of electrons have changed. If I'm positive, I will lose electrons. If I'm negative, I have to add more electrons to the total. The last thing we'll add, because we know for ions, there are charges, so we have to put the brackets and the charge on it. So in this case, in order to have the right number of electrons, I need 8 total, because I'll have 6 from the oxygen, 1 from the hydrogen, and then 1 from the -1 charge. Now hydrogen, we said, was one of those duet rules, so I'm not going to add any electrons to it, but I need to make the oxygen stable with 8. So in this situation, I've got the 8 around the oxygen. Hydrogen has the 2 that it needs. And when I count for the total, I have only 8 in the whole drawing. So I have the right number. The last step is to add the brackets in the charge. So for any polyatomic ion, we treat it the same way. The most important step is accounting for the charge in my valence electron total. And then when I check at the end, as long as everything matches up, we are good to go. At this point, you should now attempt the front side of the Lewis structure practice using these rules that you have written down.